Hello, I'm Michael. I am presenting today about about some special hardware that is reported to be really cool for computer image and all stuff. And you'll hear that whining in the background is not Garrett's stomach looking for lunch, but actually the computer that we are having running right here, which is good on Garrett's view right here. And you can see that I have a whole bunch of things plugged in. We'll also tell you that we're over in the kids' room today, and so it's freezing cold in here. And that's why my friend is putting on his gloves, as we didn't get our normal room. But let us go on with what we're talking about. So on the PowerPoint here, you can see that I have a picture, and it's the same actual case as the one I'm running right here, and you can see the person's hand holding it. And so this is a Hikey970. It was released just late mid last year. It's still available out there at a pretty high price. You can see you'll buy a development board and the case, the power plug. Strangely enough, you also get, and this was not endear it to my heart, a dongle to do emergency reboots by an emergency terminal. I'm happy to say I haven't used that, but that comes plus the case and the 12-volt 2-amp power supply. And so what you're getting is a ARM dual-core system. It's got a neural net processor in there. It's got a small GPU. And one of the other really crazy things this has is they have put an image inside of super fast memory that is directly connected to the processor so that it boots instantly. And so this is quote unquote fast boot. Now, I'll turn the screen a little bit so you can see my crazy monitor here. Well, that's not coming off too well, so never mind. We'll just, here in the room, watch. I'll just unplug this, and it's dead now. Notice it's quiet now. And now we'll put it back on, and when here in the room, we can watch power, and the signal hasn't come just yet, which is the monitor's waiting for it, but that's the longest boot I've had. And there it goes. And so it booted in about 30 seconds or better.
3 or 4.
Yeah.
Wow, that's quick.
Yeah. So, but that is faster than the Apple, and certainly faster than the Pi Top.
Yeah.
And so that was, and then in case you need to know the password for this high-tech security system, it's the same as the mysterious
Hello, welcome.
Hunya user.
You found us.
Well, look, another person has found us, and we'll continue on, and maybe she introduces herself later. You can find a cold chair somewhere over there. Yeah, and so, and this came loaded with the Android image, and I'm not an Android fan. It has nothing to do with whether I like Androids or not. It's simply I haven't spent the time to learn Android. And so, but let's talk about what our adventure was trying to make this crazy piece of hardware work. And so I purchased as an alternative, remembering what I wrote in my notes here, an alternative to the Raspberry Pi, because I have a lot of Raspberry Pis, but they all, to me, are a bit too slow for anything. And so this was reportedly 10 times faster, and I was curious if it would be faster than my Apple computer or some of my Windows computers, and so it became interesting to me to do it. So this is running a Cortex, I'm looking at my notes here, A73, which is their latest one, and a Cortex A53, which is what runs Raspberry Pis at the same time. So it has 4 and 4 of those in there. So there's effectively 8 cores in here. I've never quite understood what the 2 cores sets are doing, the processors, but I'm not a processor guy. But I've seen this in a lot of new hardware out there in the on the edges for microcontrollers, as I'm seeing a lot of them with the 2 processor model in them now. And so that's what this is. It has built-in Wi-Fi, but I have had to use an antenna because I couldn't get the Wi-Fi to talk to anything once I booted in Linux. And I believe that has to do with that the people who made the image, you have to compile in device drivers into Linux. So if those are obscure device drivers, they won't be in a regular image. You would then have to do a full make and compile them in. And so I believe it's not in the image. It could be in there and I just misunderstood it. But I was very happy that worked, and who cares after that. And so then, so I assembled this, and you'll notice that I have heat sinks and all that whining noise. Where's my other heat? Oh, and it came with another heat sink, which actually goes on the processor. But you will notice that it has a problem, is there's plastic in the way. And so it did make me nervous that they gave me extra heavy heat sink and fan for this. And so I did. Put it on. Yeah, and I can't put it on. And I then looked at some of the internet stuff on the 960, the predecessor. And there is a picture of a guy with a heat sink that is 8 inches tall with copper, coming out all over the place. And he said, and the note was on it, "I'm happy that my new 970 doesn't require this." So what? Did it at least heat a room? Yes, that's kind of, I was thinking, in this room, if we only had the 960, we'd all be comfortable. But and then the other thing was that, and I'll show it again on this one, the high-tech fan uses jumper wires to plug in, which meant that I then had to find the documentation on where you would plug those in. So I was looking for the nice, clear fan location like you have on all really good boards. Yeah. Well, I never found that. And what you have to do is plug it right into the GPIO board. And by the way, as I said in my notes here, when I plugged it the first time, it sounded like it was going to take off. And then I realized that was going to be 1.8 volt fan and not a 3.3 volt fan.
Oh, yeah. Yeah, that's the audio.
Okay, there we go. Okay.
Microphone too.
Good idea. We're getting ring out of the room. Okay, good. We got it. All right. But you can see my cute little cartoons on our presentation.
So you're lucky you didn't find things when you did that.
Yeah, I know.
I plugged in the wrong.
Yeah, I was very happy.
And it was like,
yeah,
it comes out.
Well, I won't also admit that I might have plugged it in the wrong plugs originally. I'm wondering why that happened. And eventually read the instructions correctly and plugged it into the right. And you'll see that, and you can see the easy mistake to make. The ground is on the end. Don't use that next pin and plug in the other side. So that's really cool. I was, when I originally read them, I had them next to each other. And then I realized, no, it doesn't get hot, actually. Even this doesn't get hot. Yeah. So I was happy it didn't get hot. So that was my first one. And so then I connected it to my old big monitor that I use for my Raspberry Pis. And it came up as a phone. Now, what I mean by that is it offered to dial. There's no phone in there, but the image it comes with is effectively a phone image. So I was, it was even asking me about my extra minutes and if I wanted to use them. So yeah, I was. Yeah. And so, and it says here, I then carefully read the directions. I read a lot of directions. I went searching on the internet for a lot. And then I eventually had to download on the Apple computer here, the Android SDK to allow you to update the Android computer. And then I had to plug a USB 3 into here, which by the way, it came in the box when I left it at the house, but it also came with a USB C to talk to it. And it goes here, not there. No. Apparently this is the debugging one, and this is the console one. And so I eventually learned that underneath, I was running a kernel Linux in Android, and but no distro. So there was no, no commands, no shell, no real bash. Just absolute minimum capabilities. And then I downloaded the Debian or Debian image with TensorFlow from LeMaker in Shanghai, and they were the only people that had images for this thing. Actually, they also sell this fine hardware. And so that got really ugly because nothing worked after that. Not my screen, I got the LeMaker screen, but my screen didn't fit anymore. And I was going through all the web pages of trying to figure out how to make a Debian Stretch 9.4 actually talk to a 1080p screen. And that was just unsuccessful. So, oh, I didn't. I didn't correct the spelling on this one. And so, so I was happy that I had bought the kit though for this, because this is 12 volts and 2 amps. That's not my normal plugins. It's usually 5 and 2 amps. And then they came with the converter for the. Apparently, this is the wrong barrel connector, so they give you a converter for the barrel connector also. So if you had bought this, it would not have fit in there. And then and then of course the case, the heat sink, and all of that. And so I couldn't get anything to work, so I put it away again. And then so then I went and played with my cool portable screen here, which is powered off of a USB. And so it's a one of those little purchases I made just for myself, because I wanted to light only USB powered screens, get rid of all the cables and everything. And so I'm very happy with this. And this is the older model, because I was going to connect it to older systems, back to Raspberry Pis. And so, and I connected it to this, and nothing worked. And I re-imaged that. And then I finally took the power for this screen and plugged it over here in the Apple.
Yep.
And it booted. And so apparently I can't have any powered USB from this thing. So you'll notice I'm using an old-fashioned non-powered USB hub here. And so I'm drawing almost no power. And then it started to work again. So that, back to the heat sink had warned me that this thing's got power challenges in it. And so apparently don't power anything off the USB if you want to see it. And so that was part of my learning. And then I got to buy a 9.4 on there, and I discovered I had an ancient version of Python. And then I discovered that there are no distros for Cortex A73s for anything. So LeMaker has made the distro for this, but I couldn't get Anaconda because there is no distro for this. And I tried to load an A71 distro on it, and I got a warning, are you sure you want to do that? I said no. And so, and then I got more enjoyment from Debian as I discovered that if you wanted Python 3.6, you have to go into the Debian setup for wget and tell it to go to the testing version of Debian. And there they have a version of Python 9.6. And so I had to hack the Linux distro to be willing to get the test versions of Python from the Debian maintenance people to be able to even run Python 9.6 on there. I'm sorry, 6.3.6.
I was going to say, I have the latest one.
Not yet. We don't need 9 yet. Next week, maybe. Yeah, maybe next week. And so that
in the future.
So that was, and the reason I wanted that was because there's an Anaconda versions that will run for that version. And so I was hoping if I could at least get the Python, that I could get in. No, there are no distros that will run on it. So I cannot get Anaconda, and you have to install everything by yourself. And then I rented out of Distros trying to load.
Yeah, is it SSD? Does it have a?
It has a special fast boot memory in it. I'm not quite sure I understand it yet, but effectively image that you load into this is a phone image, and it's designed to boot really fast, so it's in a special storage area.
So it's not the Windows phone.
Android?
No, it's not. It's,
Windows.
no, it's not the Windows phone. And so all of this
Yeah.
made me really not love this machine anymore. Yes, I was regretting the $300 that I had spent on this blinking box, but but then we finally got something working. So I went in and cut out all the code that used numpy.
Yeah.
I had to then go reload idle
Yeah.
because it got disappeared by the Debian update when I changed to 3.6. It deleted the idle that I had before. And so I got idle running this one for 3.6. And what I did, and this is the only really interesting information I had. So I took the Apple, the Pi top, which is a Raspberry Pi, and this, and I went out to GitHub and saved off my code for all of them, and I loaded all the code, same code on all of them, and ran a extremely inefficient calculation of pi by using what effectively is a dartboard algorithm for it, which is where you measure, and the ratio tells you will give you an approximation of pi. And so I was running the Apple here is a 3 gigahertz Intel i7, and that 8 doesn't mean anything. Using the distro from not using the Super Intel version. So I didn't actually install that. It was running it on, but this one just runs the Apple one. And then on the Raspberry Pi, I was using the 3.5 regular distro. That's a 1.4 gigahertz Cortex A53 over there. And then on the HiKey, I got a 3.6 version of idle running over there. And so the answer is that's where the 8 comes from on the editing. So the Apple runs my crazy program in 8 seconds. The Raspberry Pi is 96 seconds. And this was the interesting part, 16 seconds for the HiKey over here. And that was a starter because I was expecting 96. I was expecting it to be in the same neighborhood as the Pi top. And remember, this is just running a Python program, so it's a single thread core.
Yeah. And
so we are measuring effectively just the core. And so the single thread core of the high top is as advertised 10 times per. I think again. No, I just basically just let the distros alone. So I got but it should be. Yeah.
Because the problem we see with Python on our desktop is we give everybody a giant memory. It runs great for the first 100 users.
Yeah.
But as soon as the 101st user comes on, nothing happens. So, we're saying, well, give them less memory, and then they will run better and become more users. So I was wondering if maybe you're giving it so much memory that this thing is not efficient, or
well, it fit with,
I don't know.
Yeah, it fit with the literature that this was 10 times faster. And when I watched it, I saw one core here. And I was able to keep using the system, so I had no more than 2 cores at the most. And I know that this one only has 1 core. So it was a close to apples and apples for extremely simple. How fast does it?
But you just gotta think that there's gotta be something wrong with the difference between,
Well, I will tell you, when I used this, I was happy. When I was using the internet and editing on this one, I was happy. This is my normal, I can't stand using Raspberry Pi because it's so slow. Box over there. And my Apple runs, of course, really fast. So it fit with my expectation. So, because that was my experience on the machines also. So I would say that the literature is correct. The HiKey is 10 times faster than a Raspberry Pi.
Okay, well, at least that one.
Yeah, and that was the question I had.
Mm.
And then now the challenges I had, I can't get to the NPU on this thing in Linux. And there's no literature, no anything on how to get to it. And the maker here, who made the image, has no documentation on how to get to
Well,
the
that's useful.
NPU. I looked at Heng has literature on how to do it as an Android, and they have a demo, and I put it here. You can just look it up on there. They call it their High AI interface. It's all in Android. It is TensorFlow, and it is you're able to do, according to their pictures and what I read on the internet, people have been able to do the famous take a picture of your dog, what type of dog, here's the picture comes up, which we've actually done also. So apparently, and then the literature says that this phone is faster than all the other phones because it can do that imaging and hardware. And from what I could tell, that this is pretty fast. And I'm going to turn it off now so I can get rid of the
noise.
The noise for a minute. So this is Debian running. They said they had an Ubuntu version. I tried to load it, it came up as Debian again, so I decided to stop. And so my conclusions are: I never got the Wi-Fi to work. I had to use my little antenna. It is 10 times faster. The literature seems to be correct, but the NPU is unreachable, and all you can do is use their Android version of it. So it looks like it's not open hardware. It's not. There's nothing out of the internet, and no one is supporting it in the open community because it's not open. Now, I suspect if I spoke Chinese and if I was in Shanghai, there might be some people there that might be working on it because my experience in the hacker community is that China has its own way of doing things. Yeah. And so you might have some people working on something there. But at $300 a copy, even China might not be too excited to log into it. And it has a huge amount of hardware in it. It's an insanely complicated build. Of which none of it we're using. Yeah. And so that's the that is the end of the presentation. But we will do a demo for all of you to run all three of these. It's worth actually getting through. After all the work, you should at least see that I did actually run all.
Yeah.
And but we'll ask for any questions at the moment. And you can see we have our last comment about artificial intelligence.
That's true. Yep. All right. Vamshi, do you have any questions? Are you there, Vamshi?
That's correct. I don't have any questions.
Okay.
All right.
Well, what about this? How much was this?
Oh, that's a couple $100 too.
Yeah. That's
and
nice.
And
this keyboard?
And my retro keyboard's a couple $100 too. Yeah.
I like that.
But I wanted this because I wanted to be able to have a really light monitor that I could walk around. And you've got these little tiny Raspberry Pis and these things. Then to bring the and then put it down and then try to power it and all that. So I decided, these are expensive.
I'd like to put one of these behind a mirror.
Oh yeah, well there's some people who do that. There's other versions. Look on the internet. There's cheaper versions of that. Yeah. And you need one that someone knows how to make it talk to whatever hardware you're doing.
Like a Raspberry Pi.
Yeah, because you want to make sure that whatever you get actually talks. This is a lot of screens that don't work. So let's bring this back up, and so we'll go over here for the demo now. We'll go over here to the Apple, and I have idling. At least I did. Here's our exciting program. It's out on GitHub. What it does is it uses a Monte Carlo to estimate pi. It's really bad at it. And what it does is it actually just randomly shoots dots into a square and says, is it within in the circle? If it's not, in the circle. It doesn't count. If it is, it does. That creates a ratio that is equivalent to pi. But it's only as good as your calculation, and it's extremely slow. But it does give you, it is fun to play with. So we will run our piece of crap program, and here we go. Why don't you take 10 minutes now? Come on. Should only be 9 seconds long. Yeah.
So this is, you're going to run it on each one
so,
of them?
look, it was 13 seconds now.
Probably needed to warm up the cache.
Yeah, I suspect that we're going. So we took, this time, 13 seconds on the Apple. Of course, we also have all this going on the Apple. When I ran it, I didn't have that much going on. So we'll give the Apple an excuse for that, or a mulligan, if you like. So now we'll bring back up the world's loudest and ridiculously overpriced computer, and we'll have the screen.
Yeah, you'll have to run that out in the garage.
Yeah. If only it had that heat effect, you would do something. All right, we have a screen here.
Which repository is your Pi programming? Which repository is
The
your
GitHub?
A GitHub Aloha Wild
yes.
is the repo. It's Python class.
And
Python.
you can look at your
Yeah.
GitHub presentation.
And I've got and it's PyCode.
Or whatever.
Yeah. Yeah.
So this is the so the guys online can't see this, but we're going to log in. Log in, and we're going to run the same unexciting program by bringing up idle. And so we will go to the programming section of our bind here, and we will open a recent file, which is Pi. And this is exactly the same source code.
Wait, did you write this one, or is it a GitHub project?
I wrote this one.
Oh, cool.
Yeah, I wrote this as my, oops, oh, goodness. Yeah, try not to look at that. Yeah, I love this distribution. I love this. And so we will run this module, and you will see that we're at 3.6. So I did actually get 3.6 in here, and now we will watch it run. And we should notice that it's January 3rd, 2019. Paint is still drying on this one, and we managed to run it in 15 seconds. And you can see the answer came up with 3.1489.
Are you calculating pi? Or?
Oh, yes. And you can see it's great.
16 seconds.
Yeah. It's It's only as good as your MATLAB. And this is Python's math library. This is the standard Python library. I wouldn't recommend doing more than balancing your checking account. That, you might want to think about it for Python. So this took 16 seconds. So now we'll turn on the PyTop over here, which is yet another machine. And this has a Raspberry Pi in it. This is the B+ version, the brand new one without, this is the, and this is not the newest one, so they reduced the hardware. This is the one with all the newest components. And you can see, back to, it'll take a little while to start up. But even this one is now running reasonably fast. Welcome to my my PyTop, and a warning that yes, your security sucks wild. Yeah. And so here we are on Raspberry Pi, and I forget where I left my program. Oh, here we are. Yeah. Oh, here's programming. And we will take the case, we will get to 3. And here we are, and we will open up the same exact program. And we will run the same exact program again in Python. And we will, we can talk for a while, as this will take a minute to run. And so we have nothing running on this block. Python, huh? So all we have running on this has got a connection to the internet, and we've got GNOME up here, and that's about all we're running. And you can see in this case, we've got 27% of the CPU running because I have all the cool stuff on that. That's mostly because I know what I did that was stupid that was shut down my Raspberry Pi. And you can see it's still running. And yeah, it's still running. But yes, I do find it nerve-wracking to run. So this is a way out of date one. Yeah. This is over here is the paint is still drying on it, and this is running the old Apple version right now. So yeah.
Shouldn't that run at 100%, or why is it not using the full?
Because it's a single thread.
Yeah. Oh, it's only measuring one core.
Yeah, but it only has one core to use right now. That's it. It's right.
Is it a 4-core?
It's a single. It's 4 cores, okay. But remember, it's a single threaded process at this point. So it will. Python is pretty much single threaded.
So it must be measuring just one core then.
Yep.
Okay.
And well, no, it's measuring all the cores, but there's nothing else going on, so the rest of it is just floating in the background. So Unix takes 3-4%. You see, we just came out.
Max was like.
We just came down. So we got 92 seconds this time.
Yep.
A minute and a half, and 3.14 22.
Wow.
Yeah. So as the math processor, Raspberry Pi doesn't exist. It's all software. So there's no co-processor here, whether it's over there. I have no idea what's in there. The co-processors, that's an A73, so my memory is A73, has a math processor in it. So this one doesn't, I know that. And so, yeah, so there's our demo. So Apple runs 13 seconds. Our HiKey got 16 seconds. That was pretty good. But we know the Apple's running the video and all this stuff, so we'll give the Apple a pass. It's probably 8 seconds or 4 seconds we do the fake test. And then over here on the absolutely unbusy Raspberry Pi, we're at 92 seconds. So that means
well, that one's a loser.
Yeah. So that makes this interesting for a headless solution.
Yeah.
If you need to do some Bitcoin stuff, and yeah. But the other interesting is the economics are interesting. So for $40, you can get 96 seconds.
Yeah.
For $300, you can get 16 seconds, and for 3,000, you can get 8 seconds.
6,000, you should be able to get 4.
Yeah. And so it is an interesting economics calculation there. So I found it interesting. Now, I don't know if this will go any further than back in that brown box for any time at the moment, because I don't really have a need for a fast box that's headless right now.
Yeah.
But it is interesting to see that the phone chips are running half the speed of your favorite Intel company's chips. That is a surprise.
Oh, they are.
I wasn't expecting that.
How fast? Half.
This was half the speed of that. I would expect.
Yeah, ARMs are.
I would have
slower.
expected the ARM to be much slower than this. So this is a surprise.
Oh, yeah. There's.
That is a surprise to me. So I wasn't expecting. I didn't believe the 10x, and so I had to know.
10x. Oh, 10 times.
Yeah, the times the Raspberry Pi, because I thought that was just kind of silly.
Yeah.
You can't possibly. These Raspberry Pis just came out. Those B pluses. I couldn't possibly do much of an improvement. So that's my presentation.
Thank you, sir.